Hello, welcome to another episode of Cracking the Cryptic, and today I've got a very interesting rule set in another puzzle by Ran, who we featured once a couple of weeks ago and back again today. So we'll do that in a minute. I do want to mention, of course, the Arrow Sudoku app, which is newly out and available on 3 different platforms. The links are all in the description field of this video. Do give it a go. It's proving very popular. Arrow Sudoku has been one of the more popular things that we've been doing over the last 6 months, and the app is a result of that. Some great constructors on there as well as ourselves. Also, of course, on Patreon, we have released the video solution to the puzzle hunt by Matthias Martinka, the Build Your Own Sudoku hunt. Very hard. It was well over 3 hours of videos in 4 separate videos. They are available to the $3 Patreons over there. And today, a crossword video as well by myself. So that's also there if you like the cryptics. Loads of stuff going on as always, and really interesting content on Patreon. We do try and keep it fresh. Now, in terms of this puzzle, what have we got here? Well, it's called the Eye of the Storm, and you can see why with these 2 spirals and 1 blue cell in the center. So normal Sudoku rules apply, and digits can't repeat in a cage, and cages show their sums. So normal killer Sudoku thus far. Along a spiral, there will be no repeated digit in any pair of successive cages. Now, what does that mean? I think we take either the grey or the white spiral. So let's look along the grey spiral from the outside, maybe. Within the first 2 successive cages, for instance, there is no repeated digit. Well, that's obvious for those 2 cages because they're in the same row where there can't be a repeated digit anyway. But if you take the next 2 successive cages, well, that's more interesting. These are 8 separate cells up here and down here, and there can't be any repeated digits within those. Now then, if we look at the 14 and the 7 cage along the spiral, there's no repeated digits within those. The 7 and the 13 also there. The 13 and the 19 taken together, no repeated digits, and the 19 and the 22, no repeated digits within there. So it's a really interesting rule set that. I've certainly never seen anything like that before. Sorry if you can hear the drilling. I thought it had finished for the day, but I'm going to go ahead anyway. There is one more rule. There are a couple of inequality signs up here, and they kind of point to the smaller number. So obviously that cell is larger than that cell. In our version, these inequality signs are grey. You may be wondering, are there any within the grey spiral that I can't see? And there aren't. There are only those 2. So those are the rules. Very interesting idea. No idea how this is going to play. Do give it a go on the link under the video. You'll have some idea of how difficult I found it based on the video length, but I don't know that at this point. But I'm going to start now. Let's get cracking. And, well, I noticed while I was going around that grey spiral, I think these are interesting. 14 and 7 here add up to 21. And that's surely got to be the digits 1, 2, 3, 4, 5, 6. Now, we are normally ready to let you know the secret of the numbers 1 to 9, which add up to 45. 45 being the 9th triangular number. Here, I'm using the fact that 21 is the 6th triangular number. So those 14 and 7, 6 different digits in 6 cells, have to be 1, 2, 3, 4, 5, and 6. Now, having said this, I don't know what this tells me. Oh, hang on, I do. Yes, look, this does tell me something good. 22 and 14, those 2 add up to 36 in 8 cells. Now, that secret of the numbers 1 to 9 adding up to 45 means that those 8 cells must add up to 36 must exclude one number, obviously from the numbers 1 to 9. That number must be 9, which makes the difference between 36 and 45. Therefore, there is an 8 and a 7 within those cells, and it's got to be, they have got to both be in this 22 cage, along with 2 digits that add up to 7, which are the 2 digits missing from this cage. and in fact are the 2 digits that make up that 7 cage. That's kind of weird. I don't know how to use that, but 8 and 7 now can't be... Oh, look, let's use the rule of 45 on the top row. 22 and 17 is 39. These two add up to 6, so they're either 1, 5 or 4, 2. These have got numbers adding up to 15 and then a pair adding up to 7. So the 9 has to be in this cage, this 17 cage. But then I don't know much about what else is in it. A pair adding up to 8, obviously. Oh, that can't be 1, 7, because 7's over here. So it's either 9, 2, 6 or 9, 3, 5. Both of those would fix that, but I don't know what it is. Right. 9, 2, 6 or 9, 3, 5. And this has got a... I don't think anything has actually been ruled out, has it? 9, 2, 6 would have us have 1, 5 here, 7, 8, 3, 4. 9, 3, 5 would have 2, 4 here. So it's either 8, 7, 1, 6 or 8, 7, 3, 4. I think that's what I've just worked out. Yes. So... either 1, 6 or 3, 4 is the pair involving 7 there. It doesn't really let me... Oh, it means 2 and 5 are definitely in this pair and not in this pair. And still in the grey. 22 and 19. Oh, look, I've just noticed I could do the central cell. That's been available forever because the central box must add up to 45. And you can take off 2 22s, you're left with a 1. So let's just tidy up a bit of pencil marking. 1 and 5 come out of there. Right, 22 and 19 add up to 41 in 8 cells. So they're missing a 4. So the 1 has to be up here. The 4 in the central box now has to be in the 22 cage because it can't be there. There's no 4 in that or this. Does that tell me any more? Not really. It means now there's no 1 in the 13 cage, but that still leaves a number of possibilities. I'm going to have to look at the white spiral. I haven't really... Oh, look at that. 28 and 14 adds up to 42. That is a significant number because in 7 cells adding up to 42, we're missing 2 cells that add up to 3. That's 2 and 1. So these are, let's go full pencil mark. These are from 3, 4, 5, 6, 7, 8, and 9. Oh, but 14 and 14 adds up to 28. Oh, that's just as good the other way. That's missing 9 and 8. So there's no 9 and 8 down here. The 9 and 8 in this pair must be over in the 28 cage. So there's no 3 there. That's either 9, 8, 7, 4 or 9, 8, 6, 5. So the 3 is in the 14 cage. And this is either 3, 7, 4 or 3, 5, 6. So there's no 3. Yes, and these 28, sorry, and let's articulate this a little. 28 is the 7th triangular number, so 1 plus 2 plus 3, etc. up to 7 adds up to 28. So these 7 cells are the numbers 1, 2, 3, 4, 5, 6, 7. This 14 cage has 1 and 2 in it, plus either 7, 4 or 5, 6. So again, we're seeing a pair. Either 7, 4 or 5, 6 is in there. The other is in there. Go back to the original of 7, 4 or 5, 6 is in there. Now, 14 and 16 is a slightly less helpful total of 30. Oh, let's come out of the middle instead. 22 and 20, 42. They're missing 2 and 1. Oh, that's interesting. So the 2 in the central box is in this 22 cage and not in this 19 cage. Woo. No, go back to the white. So these are missing 2 and 1. So fourth, this could be 3, 9, 8. No, 20 and 15. Right, that's really useful. 35 in 5 cells has to be 5, 6, 7, 8, 9. The 5 can't be in the 15 cage. The 5 is definitely in this 20 cage. So let's take 5 out of there. Now there's a 5 in here, so there's no 5 in this cage, so there is a 5 in this cage. 7 plus 2 digits that add up to 15. So they don't include a 3. So the 3 is in this cage. 4 plus 2 digits that add up to 15 there. Oh, and look, law of leftovers, or the rule of 45, I suppose, more appropriately up here. These 3 areas taken together, 6 there we worked out from the top row, plus 16 plus 19 is 41. Now you compare that with what must be 45 here, and that means this cell is 4 fewer than this cell. So that can't be 1, 3 or 4. This is now 4 less than that, 2, 3 or 4. But we know it can't be 2 because 2's in this cage. And we know it can't be 4 because there is no 4 in these 2, which add up to 41. That is a 3. First cell out of the eye of the storm we've got. So 7 up there. Now that might do stuff. Let's take out 7 from those areas. Maybe it doesn't. Oh, this could be madly frustrating. 3, 1, and a pair that adds up to 15 there. That's not 7, 8. It does do things. 1, 6, 9. So we can take 1 out of here. So this is a 3, 5, 8 triple. Let's respect the inequality sign slightly. Now 2, 4. So we can get rid of 4 here. 7, 8 is 15. I can't read that total. What am I coming to? 1, 3, 6, 8. Sorry, to 22. So 6 and 1. So no 3 there. Oh, that was very obvious from that 3. So no 6 and 2 here. That's a 3, 5, 9 set. Now we've got 3, 5, 8 here. And 1, 2 in this 14 cage. And another pair that adds up to 11 that can't be 2, 9. Can't be 3, 8. Can't be 5, 6. It is 4, 7. So that's a 1, 2, 4, 7 set. That can't be 1 there. Now this is a 3, 5, 6 cage. Now we can't have 5, 6 there. That's 4, 7, 8, 9. And the 8 being in here means that doesn't have 8, 7. This doesn't have 6, 9. And these, which don't have 1, 2 or 5, 7, 8 now, are 3, 4, 6, 9, which rolls back into the grey beautifully. 2, 5, 7, 8 there. Okay, which works with this. Right. So that is quite a lot of cages, at least filled with their candidates now. Now, 7, 1, 6, 8. No 1 in this 14 cage. It's 2, 3, 4, 5. There we go. So this doesn't have a 3 or a 4 in it. So it's a 6, 1 pair, which we can fill in. That becomes a 9, I think. Yes, 6, 1. 6 now can't be in those cells. 7 can't be in those or that. This can't be a 6. 4, 7, 8, 9. Oh, where does the 1 go in the bottom row? Got to be here. In fact, 1 also there. 4, 7, 8, 9, 1. So one of these is a 2. And the other is from... Oh, it can't be 6. Oh, so there's a 6 over here in these. Yes, I knew that. That's not thrilling. No, so 2 is definitely there, and either 3 or... No, not 5. Does that have to be 2, 3? Yes, it does. Okay, cool. So we can remove 3 from this. That's a 5, 6 pair. We can fill in 3 there now. That's not 3. This is a 4, 9 pair, so Let's take 8 out of there, put in 4, 9 in both. That's not 4, 9. 4, 9 must go in these two, so we can fill them in. That 3, 6 pair sees a 5 up there. Oh man, column 4 is coming beautifully there. So 2, they can't be 8. 4 is looking up to the top. That 2 is looking straight back down all the way to the bottom. This is such a clever puzzle, the way this is unfolding. Now, as I say that, of course, I grind to a halt, because that's the rule of Jinx. 3, 5, 9, 6 in this box must be here. 5, 8, 3, 3, 5, 9, 6. 1 has to be in one of those two cells, so it's not there. 6, 1, 3. That's not an 8. That's a 5, 7 pair. So that's not 5. 7 and 8 are definitely in these two cells. Oh, which doesn't do anything for that. Well, that can't be a 1. 1, 6, 5, 8, 3, 6. I've got this 13 cage left, which can't have a 9, 6, 3, or 1 in it. So it's made up of 3 numbers from 2, 4, 5, 7, 8. They add up to 26. I have to take out 2 numbers that add up to 13. It's got to be 8 and 5. So that's a 2, 4, 7 cage, which fixes this number rather wonderfully. 1 there. Now we've got 2, 4, 7 there and 2, 4, 7 there. 8 must be in one of those two cells. These are from 2, 4, 7, 9, and again, respecting the inequality sign reduces them. One of those twos are 5. I kind of want to just flick into beast mode, but I don't think it's available yet, if I'm honest. Right, there's a 7 there, so that can't be a 7. 1, 8, 5, 7, 3 in this row. It's got to be here, hasn't it? Good Lord. Didn't expect that. So we take 3 out of the rest of the cage. There's a 3 there and a 3 there. So the 3 in row 6 with an X-wing now has to be here. That places 3 at the top of the grid. This is a naked single. 3, 1, 2, 4, 7 it can all see. Also 9, 6 there and a 5 in one of those two cells. So it's got to be the 8. So these are from, that's 5 or 6. We can place the 9 in column 8. Does that get us the 9 here? No, it's in one of those two. Beautiful again, really elegant. Right, where do 1 and 8 go in the final column? They're kind of a naked pair. They have to go here because of that 1 and 8 looking there. In fact, I guess that was a naked single 8. One of those is a 1. That's not an 8. The 8 in this cage must be in row 6, column 6. That's not a 2. So we've got a 4, 5, 7 triple in row 6 now, which has been unbelievably helpful in some ways. So 6, 9 pair here, although I can't actually disambiguate them. One of those must be a 2 for the cage. So that's not a 2. So the 2 in this 13 cage is here in row 7. 2. That's 4 or 9. I was going to say this was 4, 6 or 9, but the 6 in the cage has gone. So now we've got a 4, 9 pair. That fixes a 7 here, which does a 4 there. The 4, 9 pair also looks across at this 6, 9 pair. And now suddenly the whole thing is beginning to unwind beautifully. So all of columns 5 and 6 done there. That's a 2, 4 pair looking at the 9, 4 pair. Let's take out the 4 and the pencil marks. This must be a right in 5. 8 to finish this box. So clever. I like this puzzle a lot. That is now an 8 because there's a 6 looking up at it. We can do the 6, 1 there as well. Row 3 is still being a bit recalcitrant. That gives us the 1 there though. 3 in one of those, not very helpful. 8 though, 8 in this box must be in this cell. So that does fix the 3. There we go. 3, 6. 3, 6, 1, 5. So we've got 2, 4, and 7 to go in there. Well, that's going to form a 2, 4, 7 triple in column 3, i.e. telling me where the 9 is, which I had not appreciated before. That completes those. This now can't be a 7. No, actually, I don't know if that resolves that row. 9, 8, 3, 4, 1, 2, 7 pair. So we get a 5, 6 pair. That's a 2 or a 7 as well. We thought that. Definitely used the rule to the fullest extent. The Storm rule. Now that has to be 2, 4, or 7. Oh, 5 there. Sorry, it's looking at the 5s here. But again, this is 2, 4, or 7. I'm kind of getting left with a lot of 2, 4s, and 7s. I've got 2 more to put in here. 2, 4, 7, and 2, 4, 7. So all the candidates now. Right, that 9 is sorting out this 4. Now we use the inequality symbol, and that actually does a ton of work in the middle. Yes, that does loads. 2 there, 7 and 4 are fixed. This must be knowable, and that's a 9, 7 there. This is a 2. I'll come back to 5s and 9s over there. 4 and 9. I've just seen I can nip over and do the 4 and 2 there. This 5, 6 pair, yeah, well, that 6 is seeing 5, 6 there. That does 5, 6 here. Now we can do 5, 9 at the top, and that is the answer to the Eye of the Storm. Really clever puzzle. I mean, very interesting rule set. Absolutely fascinating how that came together. Maybe you could do it a little more smartly by spotting the totally confined sets quicker. But interestingly, some of them worked with the maxima available. Actually, I was going to compare these two pairs of boxes in the white, but and contrast them as working in different ways. But actually, they work in the same way. This is the maximum 5 numbers adding up to 35, and that's the maximum 7 numbers adding up to 42. But in my brain, it's much more easy to see the ones missing from 1 to 9 in those two as 1 and 2, rather than that they must contain 3, 4, 5, 6, 7, 8, 9. Anyway, that's just how I think from killer experience. Hope you had fun with that puzzle. I can't imagine that you didn't. It's a really neat idea. Thank you very much to Leyran for sending it to us. Really interesting. And as always, thank you for watching and for everything you do to support the channel. We are really grateful. Hope to see you again soon. Bye for now.